A boy tries to pick up a girl in geometry class, so he says, "What's your sign? It must be 90 degrees because you are the one." But it probably helps if the girl knew that sine of 90 degrees is actually 1. And we will be looking at the sine ratios and cosine ratios in this lesson. So the sine ratio describes a relationship between the angle and the ratio of the opposite leg over the hypotenuse. So if I had a right triangle here, and I have an angle in the corner, you look across, that's your opposite leg, and you put that above the hypotenuse as your ratio. If my angle were the top angle here, my opposite leg is on bottom, that still goes on top of the hypotenuse. So it's basically opposite leg over hypotenuse. The cosine ratio is related, and it uses the adjacent leg over the hypotenuse. So we're going to use special rights to find sine and cosine. I've got my two triangles, special rights here. And so it's important to identify the opposite and adjacent leg. So for the 30 degrees, you can see the opposite leg is 1 because the side opposite the 30 is 1. For 60 degrees, the opposite leg is square root of 3, and the hypotenuse is 2. So for sine, I do opposite, which is 1, over hypotenuse, which is 2. So the sine of 30 degrees is 1/2. For cosine, I'm going to do the adjacent leg. Now don't use the hypotenuse, that's not adjacent. Use the square root of 3, that's the leg that's adjacent, over the hypotenuse. So it's square root of 3 over 2. For 60 degrees, the legs kind of switch. So you have square root of 3 is the opposite leg, and 1 is the adjacent leg. The hypotenuse is still 2 because it's the same triangle. And so when I do sine of x, I'm going to do square root of 3. So sine of 60, the opposite leg is square root of 3. Hypotenuse is 2. So I get square root of 3 over 2. For cosine, the adjacent leg is the 1. Hypotenuse is still 2. So I get 1/2. For the 45, 45, 90 triangle, we have legs of 1, and the hypotenuse is square root of 2. Both legs are 1, both the hypotenuse and, both the opposite and the adjacent legs. Well, that kind of makes sense because they're the same angles. You wouldn't think they'd be different. So sine of 45 is 1 over square root of 2. Cosine of 45 is also 1 over square root of 2. And that's because both the opposite and adjacent legs are congruent. And this is a right isosceles triangle. So let's take a look about 90 degrees and 0 degrees. So if I was trying to look at sine, and let me see if I can move my point here. Oh, I have to change my angle here. I forgot. So I can say for sine of 90 degrees, what I'm going to have here is that the adjacent leg will actually turn to 0. See how it gets, I'm going to start here. See how the adjacent leg, which is this bottom part, it starts as 0.91. So on these coordinates, that shows the adjacent leg, that shows the opposite leg. The hypotenuse here is 1. I've kind of created a circle, and I put this point on it, and you can see the different triangles I can make. They're all right triangles. That's always a right angle. But I adjust this angle here, and that gives me the insight into sine and cosine. So for sine of 90 degrees, it's going to be this opposite leg, which in this case is 0.77. And notice it gets bigger and bigger and bigger. And as I get to 90 degrees, the opposite is 1. Well, 1 over 1, because the hypotenuse is 1, is 1. Let's go backwards to 0 degrees. So the opposite leg is shrinking, and it goes down to 0. And 0 over 1 is 0. So sine of 0 degrees is 0, and sine of 90 is 1. Well, let me think about cosine. Cosine is this adjacent leg, this bottom part, which see that 0.82 in this case? That's the length of the adjacent leg. As I make the angle bigger, as I approach 90 degrees, that side goes all the way to 0. Well, cosine is adjacent over hypotenuse. My hypotenuse is 1, so 0 over 1 is 0. So cosine of 90 is 0. Cosine of 0, on the other hand, is actually 1, because you see that adjacent leg is 1, and the opposite is 0. 1 over 1 is 1. So again, cosine of 0 is 1, and cosine of 90 is 0. So for further reflection, can you explain why sine of x can never be bigger than 1? Hint, think about hypotenuse and the opposite leg. Is one of those almost always bigger than the other? Or can one be bigger? Can they switch sides? Can one be bigger and then the other one be bigger? What is the relationship between sine and cosine for complementary angles? So you probably noticed that there was a pattern when we switched from 30 to 60. And it's still sort of the same pattern for 45, 45. It's just harder to see because those two legs are congruent.